Good afternoon and welcome to our webinar dedicated to the launch of our innovative new PCD cutting tool product line. I'm Hervé Baou, Head of the International Sales at Louis Bellay. We are specialized in precision micro-machining solutions for the most demanding applications.
Hello, I'm Loïc Herly, Head of Sales for South Europe. Together with Hervé, I'm delighted to guide you through this exciting presentation. During this session, we'll explore how our breakthrough PCD technology delivers exceptional performance in watchmaking, medical device manufacturing, aerospace, and mechanical application.
During this webinar, we encourage your active participation. As you can see on at the back of the screen, there is a QR code that will allow you to submit your question in real time and which we will answer at the end of this webinar. There's also a link in the chat, but don't use the Teams chat to write your question. Really click the link. Don't hesitate to reach out. We are here to address all your technical inquiries and discuss how our solution can meet your cutting requirements.
But Hervé, tell us something. What is exactly PCD?
Yeah, good question. Just like carbide is tungsten powder bonded with cobalt, polycrystalline diamond, or PCD, is diamond powder bonded with cobalt. So we are taking the hardest material on Earth and bonding it with cobalt to give it the toughness needed for cutting. With PCD, you can machine non-ferrous material like platinum and its alloy, gold, lead-free brass, and much more. But what makes it truly powerful, you can tackle the really tough materials, gemstones, ceramics, sapphires. Every sector from watchmaking through medtech to electronics needs these capabilities. The advantages of PCD are clear: exceptional tool life and the ability to run extreme cutting conditions thanks to its incredible hardness. And as we'll show you, that changed everything.
So PCD sounds amazing, but I'm guessing there have been some challenges in bringing this technology to micro tools, haven't there?
Absolutely. Until now, when we wanted to switch from carbide to PCD micro tools, you were limited to what we could offer: straight-edged design on brazed inserts. It was the only way we could do it. At Louis Bellay, micro tools are defined for tools below 3 mm or 1/8 of an inch. But this approach had a critical limitation. We couldn't produce true micro tool because there simply wasn't room for insert design. And perhaps more importantly, we couldn't optimize the cutting geometry the way modern machining demands, like the angles, the fluid design, the surface finish. It was time for a change.
And that's where Excalibur comes into play, right?
Correct. For the first time, we can now offer PCD with geometries specifically optimized for cutting performances. Tools that combine all the advantages of PCD: the life duration, the reliability, the cutting power, with cutting edges that were impossible to achieve before. And here's the real breakthrough. We can make these optimized tools in sizes that were previously impossible. Micro diameters that unleash new possibilities for your precision machining.
Can you show us what this means in application?
What you are looking at here is a part with complex geometry, multiple pockets, depths with radius features, precision holes in various sizes, and an intricate surface finish. This part will be used in this webinar, but also will be the reference for future tests like in titanium or any other further webinars.
Let's see it in action.
Yeah, what you will see in the next slide is a real machining on peak using our Excalibur tools. This precision component is made with unfilled PEEK, a high-performance engineering polymer used in the industries like medical, aerospace, etc. This is exactly the kind of part where traditional carbide struggles. The combination of depth, precision, and the material properties create extreme demands on tool life and cutting stability. This is where Excalibur excels, delivering consistent surface quality through an entire production run without tool change. You notice now the smooth, controlled cutting action. That's the optimized geometry at work. We are running a comprehensive sequence of operation here. It starts with surface finish using a free-float helical end mills at 90 meters per minute, cutting at an aggressive feed rate with exceptional surface finish. Then we move into peripheral milling, creating the walls of the cavities with precision depth control. See how the transition in the slot operations. That's where we use our angle cutting tools to reach challenging geometries. The 1.5 mm or 59 thou diameter 90 degrees angle end mill is working at 100 meters per minute, cutting very fine features with consistent tolerances. We are also completing pocket operation with ball nose end mill for the radiuses cavities and threading out operation using our specialized whirling tool, all maintaining perfect process stability.
Wow, this production efficiency at its finest and really impressive.
Because for the drilling operation, we are using the next operation, we are using our 2 flute micro drills with a diameter of 0.45 millimeter or roughly 17 thou. Notice how the PCD geometry delivers superior chip evacuation. Chip management is handled thanks to its optimized flute design.
Can you break down the specific cutting parameters for us?
Absolutely. These are the precise parameters for each operation. Cutting speeds in meters per minute, feet per tooth, spindle RPM, and axial radial depths. Notice the consistency. We are maintaining high productivity across all operations while the tool holds its edge throughout. This is the real-world performance that translates directly to your production line. We could think that these parameters are not too high in performance, but in order to maintain low burr, and because we are working with no coolant, 100 meters per minute is a very good performance. Notice the RPM value that needs to be handled.
So what exactly is available in the Excalibur range today?
We have created 2 specialized end mills with different useful lengths, one at 1 times D and another at 2 times D. Combined with a precision 2 flute micro drill and our proven whirling tool available from S.6 to M3.0, this gives you a basic toolkit for precious metal, copper alloys, and synthetics.
Can you share us a little more details about these end mills?
Yes, we have designed our 41510 and 41520 end mills as the PCD answer to one of our best-selling carbide tools, the Series 15. That tool earned its reputation for versatility and performance, and these PCD versions raised the bar significantly. Both are engineered to excel in roughing and finishing operation across precious metals, copper alloys, and synthetic materials. Our goal was straightforward: create a cutting tool with maximum cutting power to produce burr-free parts consistently, run after run. Here are the key design features. We have integrated 6 degrees radial rake angles with center cutting capability, combined with 9 degrees angles at the diameter. The 30 degrees helix angle optimized chip evacuation and cutting dynamics. And we've reinforced the core to handle the demands of aggressive cutting. For diameters from 0.2 to 0.4 millimeter, or 8 to 16 thou, these tools feature 2 flutes. Above that number, we move to 3 flutes for additional cutting power. It's precision engineering in miniature.
We saw a drill in action during the video. Please give us some details about it.
Absolutely. Let's focus on our 4580 micro drill, and this one is special. Engineered for precious metal like platinum and copper alloys, the 4580 features a 120 degrees point with a specially thin cord. This geometry delivers exceptional performance in challenging material. Equipped with two helical flutes with a 30 degrees helix angle for superior chip evacuation, the 4580 stands out in one critical way, its diameter range. We're offering the world's smallest micro drill at just 0.1 millimeter or a bit less than 4 thou. The standard upper range goes to 0.85 millimeter, which represents 33.5 thou, but if you need larger PCD drill, we're ready to support you. Just reach out. This is where precision becomes possible.
These specifications are impressive on paper, but can we see the actual cutting-edge quality?
Yes, let's start with our end mill, the reference 41520. These images were captured using SEM scanning electron microscopy, which reveals the cutting-edge quality at an extremely high magnification. As you can see, the cutting-edge geometry is remarkably homogeneous along its entire length. There are no irregularities, no particle fallout, and no microscopic defects. Most importantly, the edge is exceptionally sharp. This sharpness is essential for achieving superior surface finishes and clean cuts when machining hard materials like ceramics or sapphire. This level of precision ensures consistent performance and extends tool life in your most demanding application.
Great! And let's now move to our twist drill reference 4580.
Once again, using SEM imaging, we can observe the same exceptional quality. The cutting edge are extremely homogeneous and sharp. Notice how they appear almost polished. And here's what makes this truly remarkable. This mirror-like finish is achieved directly through our new laser technology. There is no post-processing, no honing, no additional treatment required. The tool comes out of manufacturing process in this condition.
Why does this matter?
Because this ultra-smooth, sharp edge significantly reduces chip adhesion during drilling operations. Less chip welding means better chip evacuation, improved hole quality, and longer tool life, especially critical when drilling through hard and abrasive materials. This is the result of years of development in our laser manufacturing process, and it's what sets our PCD drills apart from conventional solutions.
This is great and nice for theory, but can you give us a practical example?
Yes, one of our customers faced a persistent problem. Carbide end mills simply weren't cutting it anymore in their Declafor finishing operation. But what's Declafor? This is a copper alloy with nickel and tin. It is used in the watch industry for movement parts and other industries. Tool life was disappointing, and they needed a solution that will let them complete production run reliably. They switched to our PCD end mill. The improvement was immediate and dramatic. They completed an entire 8,000 piece production series without a single tool change. Not one.
And when the tool finished the series?
It transitioned seamlessly to another production run. We have to say a big thank you to Jeremy Murchel for sharing this experience.
Wow, that's not just efficiency, that's transformation. Knowing Louis Bellet, I'm sure you are working on special things for the future, aren't you?
Yes, absolutely. You know us very well. Today we have the honor of exclusively previewing the next phase of Excalibur development. These new references have been specifically engineered for the hardest material: ceramics, sapphires, gemstones, and carbide. Materials that traditionally tools simply cannot handle effectively. In this expanded Excalibur range for hard material machining, you'll find specialized drills, toric end mill, and our advanced welding tools. But that's just the beginning. We're adding ball nose end mills and angle cutting tools that open entirely new possibilities for complete geometry finishing.
As you can see, they feature coolant fed capabilities, so they were the H for the coolant fed series. Can we see it in action?
Yes, let's move to the next slide. Now we are pushing into truly extreme territory, zirconium ceramic. What you are watching is a complex machining sequence on ZrO2, a material known for its extreme hardness and brittleness. Our Excalibur tool for hard materials are specifically optimized for this challenge. To help visualize the machining process more clearly, we painted our workpiece orange. This contrast allows us to see exactly what's being machined and how the tool behaves in real condition.
Oh wow, the drill turns red hot.
Yeah, and that's something remarkable actually. Despite the extreme heat generated during these operations, we were able to use the tool all the way through to completion. No premature wear, no catastrophic failure. You'll notice we're using a 12-flute high helicity end mill running at 80 meters per minute. That's no accident. The geometry and fluid design are tuned precisely for zirconia's unique properties. We are drilling with a specialized 3-flute drills reaching micro depths with perfect stability. The pocket operation demonstrates our ball-nosed tools performing intricate curves surface with remarkable precision. And our specialized working tools, where their fine geometry, are creating perfect threads formed in ceramic, which is generally one of the most challenging operations in precision machining. Notice throughout the entire sequence, smooth operation, excellent surface finish, predictable cutting force, and outstanding tool stability even under extreme thermal stress. This is PCD technology solving what was previously considered unsolvable.
Let's look at the technical parameters behind this impressive demonstration.
Louis Bellet has been redefining tooling for 78 years, and in the past years we have focused on PCD tools. These parameters, from surface finishing through deep pocketing to threading, represent months of research and optimization specifically for hard-to-machine material machining. Every setting here balances cutting speeds, feed rate, and depth to maximize tool life while maintaining the surface finish and dimensional accuracy your application demand.
So we've seen standard products, but what if customers have unique requirements?
The two Excalibur families we've shown you now cover every material compatible with PCD machining. But we know that's sometimes not enough. In real production, you often face unique challenges that standard tools can't solve. That's where our expertise becomes essential. You can see on screen just a few examples of custom engineered solutions we've created. Specialized shaped end mills, segmented cutting tools, multi-flute helical design, step drilled, you named it, we've built it. Want integrated coolant channel built directly into the tool? We have the proven technology to make that work. Need compatible designs for advanced machine interface like the 701 system? We're ready. The point is simple. We don't stop at standard products. Your challenges inspire our innovations.
Let's summarize what we've learned today. What the key takeaway for our audience?
Here's what you should take away from everything we shared today. When you have a specific requirement, our sales team and R&D specialists are ready for your challenge. But the core message is this. Thanks to finely optimized cutting geometries combined with premium-grade PCD materials, Louis Bellet now delivers cutting tools with truly exceptional tool life. Our laser technology and our mastery of it allows us to create cutting edges in PCD that were simply impossible before. Edges that cut faster, last longer, and handle materials previously thought unmachinable. Actually, we made the unmachinable machinable.
We definitely can say that this is the Excalibur promise.
Absolutely. You named it. So thank you very much for your attention to this webinar. We are now opening the question and answer session. So let's see if we do have some questions ready. Loic, have you got some questions?
I have one here.
Uh-huh.
So, is the PCD tools PCD coating? Or is it PCD massive?
No, actually, the tool we just presented are a solid PCD. So this is the PCD that is directly laser ground and shaped to your needs. So all the PCD tools we showed are really solid PCD tools, micro tools.
Only the shank is in carbide, right?
Yeah, the carbide is in shank, obviously, yes. The PCD is braced on the carbide shank, and the flute and all the cutting geometry is done with the laser grinding. Yes, thanks for the precision.
No problem. Can we use Excalibur tools in lead-free breath?
Yes. So we didn't test it with the plate we did for the video, but our customer are using that material, or actually our tool for that material. So yes, the lead-free is definitely a good material to be machined with this Excalibur tool technology.
Are there any case studies available machining orthopedic implants in titanium, HMPE, or cobalt chrome?
Yeah. So we are developing tools for machining titanium. So I think we are on the test, if I'm not mistaken.
Right.
HMPE, I think it's a synthetic material. So I definitely think that this could be machined with the PCD. Cobalt chrome, I don't think so.
No, I
It's
don't
ferrous
think.
material.
I don't think.
Yeah.
Because there are some ferrous materials in.
Absolutely. So I rather no, but maybe the Cyclonics tools can definitely hold that material and machine that material in very high productivity.
What size ranges are stocked in drills and mills?
That's a good question. Actually, you can go on our website and correct me if I'm wrong, but we have a big inventory in the end mills and drills, and I think the increment is 0.01 millimeter.
Yeah, right.
Yeah.
But for the drills, over in whole one.
Okay. Yeah. So depending on the dimension, it's 0.01, and then it's 0.05, and then it's 0.1. But I mean, you can check on our website the catalog, the brochure, and you will find all the diameters and all the dimension we do have in stock. Additional to that, if you need any special dimension, you definitely can ask us. And as of today, if we do have the raw material ready, we can handle that within 2 to 3 weeks. So it's pretty rapid.
What about etchers?
Yes, it's a good question. So the etchers are used, can be made also in a PCD. We have that also in stock. And correct me if I'm wrong as well, Loic, but I think there are with and without coolant, the engraving mills. We have both, right? Yeah.
So I have another question. Can PCD tools be regrown?
That's a good question. Actually, the technology allows us to regrind it, but in the reprocess, we are not 100% ready yet. But we are working on that in order to have that possible. But if you do have PCD tools in hand and you want us to regrind it, send us the request with the tool design if it's not ours, and we'll be able to see what can be done thanks to our laser grinding technology.
Another question. Do you have a technology center to evaluate cycle times and tool performance?
Yes, actually, we do have a technology center here in Switzerland. We do have the possibility to do tests on material you do have or machining handling that you would like to test. And actually also in the US, we have the CME Center in Minneapolis or in the suburb from Minneapolis, where we can work with them to test on high performance machines directly there. So yes, we have many possibilities and you can challenge us to test the tools. Yes, good question.
Tool life is always difficult to test, but we try to arrive to define what's the quality after some pieces.
Yes.
And that's good in our technology center.
Yeah. Absolutely.
So if you have some questions,
Yeah,
we are ready.
Yeah, I think we made the tour of it. So
if not, we are available for you.
Yeah, don't hesitate to contact us. You will see information on the screen. So reach us at louisbellet.com.ch and on our socials. So thank you very much for your attention, and we look forward to have you on the phone, per email, or in face-to-face visit. Thank you very much, and see you for the next webinar. Thank you, Loic.
Thank you, Hervé, and see you later.
Bye-bye.
Goodbye.